I think I have one more problem, and then I'm just going to leave you alone for the rest of time. Or until you take another class with me, whatever happens first. All right, so a 40-pound cart is pushed up 100 foot of... Bloody hell.
Take two.
A 40-pound cart is pushed up 100 feet. God.
Take three.
A 40-pound cart pushed 100 feet up a ramp that is a 20-degree angle with the horizontal. How much work is done? So don't even retake it. We'll just draw a picture. I'm sorry. I've had too much crack. No, it was a joke. It's a joke. Okay, so here's your cart. And it weighs, what, 40 pounds? Yes, 40 pounds. And this is 20 degrees, and it's not quite 20 degrees. Here's 40 pounds. Okay. And it is pushed up here 100 feet. And we're trying to figure out the work that it takes to get a cart that weighs 40 pounds up a 20-degree incline up 100 feet. And the bottom line is that the work is the force dot product, the distance vector. But here's the deal. We can do this a couple different ways. We could bring this in the XY plane and figure out, in fact, what the distance is, what the vector, in fact, would be. But it's just easier. What is this? This is the norm of F times the norm of D times cosine of theta, right? And this will be easier to work with if we just the norm of D, if we go in the direction of the hill, is simply 100. That's what it is. It's 100 feet. So let's think about this, how we're going to do this. First off, we're pushing it up. What force are we resisting? We're pushing it up. What's pulling it down? I mean, why doesn't it just go up by itself? It's the force of gravity. So here's the perpendicular component. Here is the force that's pulling it down. And we'll call this, I don't know, down force, right? Well, what is that? Once again, this is 20 degrees. I made the argument and actually proved a couple videos back ago that this angle here is in fact 20 degrees. So this is the long arm here. The hypotenuse is 40 pounds. So we know then that sine of 20 degrees is going to be the downward force, which I'll call dF, divided by 40 pounds. So the downward force is going to be 40 pounds times sine of 20. And so you'll notice once again what I did really is that I kind of made this a flat problem, which is just easier to figure out. I didn't quite do something right. If this is simply the real line flattened out, this would be considered downward force would be in the negative direction. But the truth is I know that the downward force is pulling it this way, so to push up against it, to get it to move, the upwards force is just the same magnitude. So I don't really have to say plus or minus. It would be proper to say in this context the downward force acting on it is minus, because it really is a vector. This is still a vector. But I just want the scalar. It turns out that the scalar version of this is going to be the same number without the minus sign. It's really important to get that distinction. It will grow on you like a fungus that you don't want, that the doctor doesn't understand and doesn't have pills for, but it will work. Okay, so what is this? Never mind. I don't know anything about that. It's my producer. He has a problem. Shh. So 40 times, I'm sorry, I'm having one of those days. So my trusty calculator says that gravity is pulling it down along this slope at 13.68 pounds, right? And once again, this is really, we're really looking for the scalar, right? And that's going to be 13.68 pounds. The pounds is not a vector. the pounds are units, but it's not a vector. Anyway, so it's going to be this is the component this way. Now we're moving it 100 feet this way, so it's going to be this times 100 feet. This is 1368, and they call this foot-pounds. This is a measure of work. If you're in the metric system, which for some reason America is not always in the metric system, this is called joules. So that's it. That's the last problem. Basically, you have everything you know to get an A on my exams if you study and work hard, and I hope that you will. We'll be making supplementary materials for this that will probably be used in other courses, and it's just going to be me doing a bunch more problems. But the truth is, you will learn more by doing problems yourself. I wish you every success in this life. Good day.